Picture the last time you filled up a car with petrol. You pulled in, swiped a card, stood there for 5 minutes while the pump did its work, and drove off. Now picture doing that with an electric car. For 15 years, the honest answer has been you can't. Even the fastest chargers on the market need 15 to 20 minutes to get a meaningful amount of range back into the battery. And that gap, more than price, more than styling, more than anything else, has been the single biggest reason ordinary drivers hesitate before going electric. But in March of 2025, a Chinese company did something that the rest of the auto industry said was years away. They built a charging platform that puts 400 kilometers, roughly 250 miles, back into a car in 5 minutes. Not in a lab, not as a concept. In cars you can walk into a showroom in China and buy today. If you enjoy stories about the engineering battles reshaping the auto industry, hit the like button because it takes real effort to put these together, and subscribe so you don't miss the next one. To understand why this matters, you first need to understand exactly what has been standing in the way of fast charging for the last decade, and why nobody had solved it properly until now. Every electric car charges through the same basic bottleneck. Electricity flows into the battery as a current, and the faster you push that current in, the more heat it generates inside the cells. Push too hard and the battery degrades faster, or in the worst case, becomes a genuine safety risk. That's why manufacturers have spent years engineering elaborate cooling systems and conservative charging curves that slow the rate down dramatically once the battery passes 50 or 60% full. Tesla's most advanced supercharger, the V4, tops out at 500 kilowatts of charging power. Most mainstream EVs on sale today peak somewhere between 150 and 250 kilowatts. Those numbers sound impressive until you do the maths on how long it actually takes to add real range, and that maths has never quite added up to gas station speed. The company that changed the equation is BYD, and the platform is called the Super E platform. BYD unveiled it in March 2025 at an event in Shenzhen, and the specification sheet reads almost like a typo. A 1,000-volt electrical architecture, paired with a charging current of 1,000 amps, delivering a peak charging power of 1,000 kilowatts, a full megawatt. That's double the peak output of Tesla's fastest charger. At its maximum rate, the system replenishes range at roughly 2 kilometers per second of charging. Do the arithmetic, and 5 minutes of charging adds close to 400 kilometers, or about 250 miles, of real driving range. BYD's chairman, Wang Chuanfu, was blunt about the ambition behind it at the launch event. He said the ultimate goal was to make charging an electric car take exactly as long as filling a petrol car, and that charging anxiety, the thing holding back mass EV adoption more than any other single factor, needed to simply disappear. This wasn't a marketing slogan dressed up as engineering. It was a stated design brief, and the specifications suggest the engineering team actually hit it. Getting there required rebuilding several fundamental pieces of an EV at once, not just tweaking one component. The battery itself is a redesigned version of BYD's Blade battery, the lithium iron phosphate pack the company has been refining since 2020. The engineering team re-engineered the internal structure of the cells to create what they describe as ultra-fast ion channels running from the positive to the negative electrode, cutting the battery's internal resistance by roughly 50%. Less internal resistance means less heat generated at a given current, which is what allows the pack to accept a charging rate of 10 C, meaning it could theoretically take a full charge in 1/10 of an hour, about 6 minutes, if it maintained peak power the entire time. The battery alone wasn't enough. Delivering and handling a full megawatt of power safely also required an entirely new generation of silicon carbide power chips, rated up to 1,500 volts, replacing the more common silicon-based chips used across most of the industry. Silicon carbide chips switch faster and waste less energy as heat, which matters enormously when you're pushing this much current through a vehicle's electronics in a matter of minutes. BYD also had to redesign the electric motor that goes with the platform, landing on a unit capable of spinning at over 30,000 RPM, the highest of any mass-produced electric motor in the industry, delivering up to 778 horsepower with a power density the company claims is unmatched by any rival. The charging infrastructure needed its own breakthrough too. A charger capable of delivering a full megawatt safely and reliably isn't something you can simply bolt onto the existing network. BYD built what it calls the world's first fully liquid-cooled megawatt flash charging terminal, rated up to 1,360 kilowatts of output. and paired each station with a 225 kilowatt-hour buffer battery that stores energy locally so the charger can deliver its peak output even in areas where the surrounding electrical grid isn't built to handle a sudden megawatt draw. That detail matters more than it might sound. Without it, deploying these chargers at scale would require rebuilding huge sections of the regional power grid first. With the buffer battery, BYD can install the stations largely independent of local grid capacity. Independent testing has backed up the headline numbers rather than just repeating BYD's marketing claims. Journalists who traveled to Shanghai for the platform's public debut watched the company's Han L sedan charge from 5% to 63% in 5 minutes flat, adding 407 kilometers of range in that window. The charging curve itself is revealing. The car started pulling in power at 464 kilowatts, climbed to its full 1,000 kilowatt peak by around the 18-second mark, held that peak for roughly 40 seconds, then gradually tapered as the battery filled. Even at 90% state of charge, a point where most fast chargers have slowed to a crawl to protect the battery, BYD's system was still delivering 600 kilowatts. That's the detail that separates a genuine engineering achievement from a headline number that only holds up for the first few seconds of a demonstration video. It's worth being precise about where this technology currently stands, because the honest picture is more nuanced than the headline suggests. The full megawatt charging experience is only available on 2 models so far, the Han L sedan and the Tang L SUV, both built specifically on the new 1000-volt architecture. You cannot retrofit an older BYD onto this charging network and expect the same speed, and the charging stations themselves are expensive and demanding to build. BYD's stated plan is to construct more than 4,000 of these megawatt-capable stations across China, a genuinely enormous infrastructure commitment, but as of now, they remain concentrated there, with the company only beginning to discuss international rollout, including roughly 300 planned stations across the UK and expansion into continental Europe and South Africa over the next couple of years. There's also a fair critique worth naming directly. BYD's own comparison that 400 kilometers in 5 minutes matches the time it takes to refuel a petrol car is true for the charging step itself, but slightly overstates the full picture, since a petrol fill-up of similar duration typically buys you more total range than 250 miles in most conventional cars. The comparison is close enough to be meaningful, but it isn't a perfect one-to-one swap, and BYD's own marketing has occasionally leaned into the comparison a little harder than the raw numbers strictly support. None of that changes what actually happened here. For over a decade, the entire global auto industry treated charging speed as a problem that would improve gradually, a few percentage points better with every new battery generation, arriving at gas station parity sometime in the distant future. BYD didn't wait for gradual. They rebuilt the battery chemistry, the power electronics, the motor, and the charging infrastructure simultaneously, and delivered a car you can buy today that charges faster than anyone outside China believed was commercially possible in 2025. The bigger story here isn't really about one platform or one company. It's about what happens when an industry's stated timeline gets compressed by years in a single announcement. Western automakers had been telling regulators and customers that megawatt charging for passenger vehicles was a 2028 or 2030 problem, something that needed years more battery development and grid investment before it became practical. BYD just proved that assumption wrong. In production vehicles, with independent journalists timing the results themselves, there's something worth sitting with in that. The technology that finally closed the gap between electric and petrol refueling didn't come out of Detroit, Stuttgart, or Silicon Valley. It came out of Shenzhen, from a company that started out making batteries for mobile phones 30 years ago and only later decided to build cars. The rest of the industry is now working out how quickly it can catch up. If a car that charged in 5 minutes for 250 miles of range showed up at a dealership near you tomorrow, would that be the thing that finally gets you into an EV? Let me know in the comments.